Good morning dear kids. Today I'll be taking a new topic, that is Voronoi diagrams. Voronoi diagrams, as you can see, I've already drawn on the screen. In Voronoi diagrams I'll be covering today what are the edges, what are the sides, what are the regions, and what are the intersection points. Here if you can see these points, these are A, B, C, D. You can see that these are located into your Cartesian plane into different regions. So this entire region belongs to A, this belongs to D, and this belongs to C, like that. So we saw regions here. Now we'll be seeing what these points are. These points, if it is B, this is called as site B, site. S-I-T-E, site. Site A, site D, and site C. And in between these two sides, what I'll be doing, I'll be constructing a perpendicular bisector. I'll be constructing a perpendicular bisector in between two adjacent sides. Can you see this? And these perpendicular bisectors, where they intersect, I'll put it any point here. I have put it Q. That will be called as intersection point. Now many kids have that in mind, that what are these Voronoi diagram and for what purpose they are used for. So Voronoi diagram is nothing but it's a partition of a plane into different regions. Correct? Okay, we can say that these Voronoi diagrams are used to calculate the amount of rainfall, the amount of forestation, and many other things where you have to compare between two regions. And these regions, different regions, are also called as Voronoi cells. Come on, let's take with first example. In my first example, if I have given you the coordinates of the sides, different sides, that is A minus 5, 0, B that is 1, 6, and C that is 7, 4. You have to construct a Voronoi diagram. Let's start. So I have already plotted the points, and we have to now construct the Voronoi diagram, which means we have to take the perpendicular bisector between two given points. So first we will take perpendicular bisector, that is PB, between A and B. For that, let's go for the midpoint of AB. That will be minus 5 plus 1 upon 2, 0 plus 6 upon 2. That will be minus 2 comma 3. And let's also find the slope of, or you can say the gradient of AB. That will be 6 minus 0 and 1 minus 5. That will be 6 upon 6, that is 1. So the perpendicular of AB has slope minus 1 because it's a perpendicular of AB. So it has slope, I'll write it here, perpendicular of AB, perpendicular bisector of AB has slope minus 1, and it passes through points minus 2 comma 3. Am I correct? So we can make the equation for perpendicular bisector. We have the slope and we have the points through which it passes. So make the equation. Once you got the equation, you can plot the perpendicular bisector onto your graph. That will be, I'll just erase this. Okay. That will be somewhere here. Similarly, we have to find the perpendicular bisector between BC as well as AC. Now you can see the green color lines, these are the perpendicular bisectors of AB, BC and AC. And you can notice if I just stretch these are going to intersect at one point. That point will be called as intersection point. A, B, C are called as sides. Now this region this region will be A's region. So this is A's region. This is B's. And this is C's region. So we have drawn Voronoi diagram. Let's go back and check what is our next question. Your next question is determine the equation of perpendicular bisector AC. We must have already done that in this thing while drawing the perpendicular bisector. Let's read out the third question, and it says use your diagram to determine the closest side to 0, 0, 4, 4, 3, minus 4 and 2, minus 1. Let's go for it. 0, 0. Let's see 0, 0 lies in which region? Can we say it is closest to A? So you can write it A there. For 0, 0, it is closest to A. Your next is 4, 4 and it is closest to C. And similarly, you have to check the rest 2 points where they lie. There will be some points if the coordinates are such, they can lie on the perpendicular bisector itself. Let's read out the next question, and it says that show that point minus 2, 3 is equidistant from sides AB. Okay, let's do it. Your A point was given as minus 5, 0. B was 1, 6 and point P minus 2, 3. You have to prove that it is equidistant from A as well as from B. That means you have to use your distance formula, that is distance of AP. You have to take it under root x2 minus x1 the whole square plus, okay, I have written wrong, just 1 second. It is x2 minus x1 the whole square plus y2 minus y1 the whole square. You have to solve this, as well as you have to take up the distance of PB, that is under root 1 minus 2 the whole square plus 6 minus 3 the whole square. And if you get the values of both distances to be same, you will say that P is equidistant from A as well as B.